The sun's corona, its wispy outer atmosphere, has long befuddled scientists. The sun's surface is 5,500 degrees Celsius, yet temperatures in the corona, much farther out, soar to more than 1,000,000 degrees. NASA is about to launch a mission not only to study the corona, but fly into it. After the Parker Solar Probe launches in August, it will sidle right up to the sun and spend the next 6 years conducting 24 flybys through its scorching corona. Its closest pass will bring it 10 times closer to the sun than Mercury's orbit, shattering previous records. To protect delicate scientific instruments from the immense heat, the probe is equipped with a shield made of carbon foam, similar to the materials that protected the nose cone of the space shuttle. The Parker probe will repeatedly plunge into the sun's corona, beaming back measurements of the tangled net of magnetic fields that shape it. Most scientists think that the sun's magnetic fields are responsible for heating the corona by somehow transferring energy from a bubbling cauldron of plasma at the sun's surface. In one theory, the magnetic fields that protrude from the sun move around and get tangled up. When the field lines suddenly snap into a more stable arrangement in a process called magnetic reconnection, vast amounts of energy are released into the surrounding plasma of the corona. The process could also be happening on a much smaller scale, with nanoflares constantly going off, each as powerful as a 50 megaton hydrogen bomb. A second theory suggests that the motion of the bubbling plasma cells on the sun's surface excites waves in the magnetic field lines that course outward. The wiggling of the field lines heats nearby particles. Researchers hope that Parker will also help explain another conundrum: how plasma particles in the solar wind escape into the solar system. The magnetic field in the sun's corona has a tight hold on charged particles, but somewhere at the edge of the corona, they break free of the sun's gravity, rocketing out into the solar system at hundreds of kilometers per second. These particles should slow down and cool off the farther away they get from the sun, but they don't. They're propelled forward by some unknown energy. By recording the small-scale physics of the plasma it flies through, the Parker probe will pinpoint where the wind takes flight and narrow the possible mechanisms that could launch it. Understanding the solar wind could help us better predict dangerous solar storms, launched by extreme events called coronal mass ejections. In these storms, the solar wind overpowers the shield of the Earth's magnetic field, potentially crippling satellites and electrical grids. The Parker Solar Probe's future is definitely going to be bright. Good thing it has some shades.